Hello, and welcome to Grandad Does Stuff. In this episode, I'm going to be looking at a continuous integration product from Woodpecker. I'm going to spin it up on Docker for Windows. I'm going to connect it to GitHub, get an Nginx SSL terminator to securely access it from the public internet, and tunnel it through my broadband router. So if that's of interest to you, stick around and let's do some stuff. I'm doing this because in my last video, Solar Controller, I promised that I would do a follow-up video adding some extra tests. And this has shown up a problem with the Grandad Does Stuff monorepo. Currently, I'm very sloppy. I just push commits to main. Whilst that's worked for me so far, it's not going to work going forward. So I need to get into the standard discipline of pushing to a branch, creating a merge request, and merging to main. And if I'm going to do that, I should really run the tests automatically. And I don't want to be rerunning the Solar Controller tests simply because I've updated a README in another directory. So I was looking for a CI solution that would enable me to selectively work on the bits of the repository that have changed. In the past, I've used Jenkins and Drone, but I couldn't see an easy way to do that. I'm not saying there isn't an easy way to do it. I just couldn't see it. As I didn't have either of those installed at the moment, and I had to install something new, and I saw this great piece of syntax in Woodpecker CI, I thought I'd give that a go. So let me show you the syntax I wanted. So this is going to run this step of the build when one of these elements or something in Solar Controller has changed. That's exactly what I was looking for. So let's have a look at the solution that I've ended up with. So let's flip over to PyCharm. Let's start with my pipeline as a whole. And this to me looks very like the drone syntax that it is. I mean, people out there are probably telling me it's very different, but it's a YAML file telling me what's going to happen. This is stored in my monorepo, the Grandad Does Stuff, in kind of a well-known path. It's in this .woodpecker directory. Woodpecker will then run everything that's in that directory that's a YAML file. And it will say whenever there's a push event, and you can specify various branches, etc. as well. But I've only got my monorepo connected to this. They say run these steps. And I'm going to have a step for my Solar Controller, which is going to run on a Python image. And as I say, whenever anything in the Solar Controller has changed, or if anything in here has changed, I might be changing the test definitions down here, run the following commands, just echo testing, change to the Solar Controller directory, and run the bit of Python that's going to discover and run the tests. So that's what we're going to run. I will have a look at that throughout the entire stack of stuff that I've got. And I want to do a fairly quick pass through that stack without too many deviations to the side to set up certificates and connect to GitHub. Let's just understand how the land lies, and then I'll go down all those paths and get all the connections set up. Otherwise, you get lost in all the detail without understanding the flow. So if I come to my Docker Compose .yaml, it has three services in it. It's got the Woodpecker agent, which is the thing that's going to run this pipeline file. It's got the Woodpecker server that's going to connect out to GitHub and take instructions from there as things change and serve the UI that we'll have a look at later. But that Woodpecker server runs as HTTP. And just to convert that into HTTPS, there's going to be an Nginx server on the top of it. So let's have a quick look at those things in detail. This is almost a standard out-the-box Woodpecker agent configuration that you'll see on their website. It's got the image that it will run. I've added this restart always to it, and I've added that to all these three services. And all that means is that if I shut my desktop machine down, when it starts up again and Docker for Windows starts up, this pod will start back up again, container will start back up, and it'll be like it was never switched off, and it'll be ready to accept all the push requests that come in from GitHub. The command equals agent is just to do with that image there to tell it what program to run. It depends on the Woodpecker server. There's no point having the agent as it started without the server because it tries to register with the server. There's a couple of volumes that it mounts. There's one which is this Woodpecker agent config, This is in Windows, so // means it's in the local directory. So it's my agent config. I will quickly go down this rabbit hole. It's just got this agent ID equals 1. So not a great deal there. I probably didn't need to mount that as a directory. I probably could have just let it recreate that every time, but never mind. Next, it's got this strange volume. It looks like it's a Unix mount and it's getting the Docker socket. That does work on Docker for Windows, and it is needed because the Woodpecker agent needs to be able to connect to the Docker server to be able to pull that image and to run that image and then exec to it to actually run those commands. So that bit of syntax looks odd in a Windows context, but it does work and it is required. Then there's the environment that this runs up in. When this starts up, as I say, it needs to connect to the Woodpecker server, which it finds on that locally resolved address, which is that service name there, and on a well-known port 9000, which I assume is just some kind of API port for the Woodpecker server. And then for the Woodpecker server to know that it can trust this Woodpecker agent, they share a secret. I'll show you in the Woodpecker server as well. And that gets plumbed in there. You'll see several of these variables get plumbed in with this $bracket syntax. And I'll show you those things later, but let's get through the main flow first. So this is the Woodpecker agent. Let's have a look at the Woodpecker server. So this is the thing that serves the UI that we'll have a look at in a minute, and also the connection out to GitHub. So again, pretty much verbatim out of the Woodpecker docs, apart from the restart. We've got the image there. It must have an entry point or a command in the image because there's no other command in here. It's got a volume that's mounted on it, which comes out to this Woodpecker server data. And that's just the storage for a SQL-like database that stores all the configuration and output the Woodpecker server needs. And then we've got the environment. Out of the box, you have Woodpecker open set to true. And that means that on the login page, you can log in with any GitHub account. And that means if it's on a public internet, which it needs to be for GitHub to be able to speak back to it and send out the push hooks or the web hooks that it needs, anyone would be able to log into your Woodpecker server. That's not what you want. So what I've done with mine is I set that to true. I logged in, and I'll tell you about the login process in a minute. Now I've got this set to false, and that should stop anyone else from logging in. Woodpecker needs to have what its public IP address is. Now, that will be the public IP address of my router and the port of my router. I'll show you the details of all that later on, and that's going to get mapped through the Nginx server. But it needs to know what that final external public address is. This says GitHub equals true. Now, Woodpecker can connect to a number of different repository types. They call them forges. And this is obviously set up to speak to GitHub. And when it speaks to GitHub, GitHub says, well, I've got millions of accounts, millions of repos. What do you want to talk about? So it needs to know what its client ID is. And then, so well, you got the client ID. How do I trust you? What's the secret? So it's got a secret. It's a bit like a username password pair to get into GitHub. And again, later I'll show you how to sort those out. And finally, it's got that secret, which is shared with the Woodpecker agent. The interesting thing about this is it doesn't expose any ports. The ports are always accessible on this internal network that Docker Compose will have, which is how the Woodpecker agent can use its port 9000 to get here. We'll see in a minute that this exposes port 8000 as well for the web front end. And I'll show you in a minute where that gets configured, which is in the Nginx server. Nginx is just a very small secure proxy, and it's a good way to terminate the SSL. So these are the mappings for the SSL information. So it needs a key and a certificate. Again, it's always going to restart. And this has got a port mapping. So this will map port 8443 on my box, on my desktop machine, to port 443 internally within Nginx. And again, there's nothing in here that tells us how it connects to the Woodpecker server. And that connection information is in that nginx.conf file. So let's have a quick look at that one. So this is nginx conf. Don't worry too much about the events. That is just a required piece of syntax for the nginx conf file. The worker connections basically just says how many separate threads of activity can this nginx connection have. 1024 seems to be a pretty low number. For me, my use case here, probably one would be enough, but I've just left it a pretty standard low default. This stream here, I'm not sure exactly what a stream is, but the easiest way to read this is to say, this is a server part, which is the configuration for nginx. It's going to listen on port 443 on SSL. Those are the server certificates, which get mapped via the Docker Compose file out to my files down here. Come on to those later. This was a standard bit of configuration, which I haven't changed. I have to confess I don't necessarily understand all of it. I guess a session timeout is, and handshake timeouts and various things. So these are a standard set of protocols here. I might take out could take out some of the lower ones, I guess, but I haven't touched any of that, and I'm sure it'll be secure enough. The bit of magic happens is that when it's listened on port 443, it's going to do a proxy pass to this Woodpecker backend. The Woodpecker backend here, the name has to links to a server called Woodpecker server on port 80,000. And that Woodpecker server is the name that is here. That has to match. And that's how this nginx knows to go to that server, all connected by its Docker container registry lookups to get the name. And then port 8000 is a standard port there. So currently we've got from the pipeline all the way through the agent to the server out to nginx to port 8443 on my host machine. So if I now have a look at this is my broadband router configuration. I have quite a lot of other stuff running, which I don't necessarily want to make publicly available. But I have port 8443, which is my external port from my router, maps to an internal port, i.e. on my machine of 8443 onto my host machine. So that's my machine that's running Docker for Windows. So from my public IP address, which I have got, I paid an extra £5 a couple of years ago to get a static IP address that I can just use and makes things easy for me. If you haven't got a static IP address or they're going to charge you some ridiculous money for it, there's quite a few domain name services. So I have used ownimage. Goodness knows what on these services to map to my home machine. And then there's a program that runs as well. You can run in the router, or it can run as a little agent on your machine. Keep saying that this is my IP address. You save it to this DNS entry, and so you can always use the name, and even if your IP address changes, the DNS will change, and so the link will still work. And there's quite a few of those services out there. I can probably think of half a dozen off the top of my head. I'll put one that I normally use in the comments, and there's a free tier on this. I don't think I've ever paid for one of these because I've only got one IP address, so kind of they give you that for free. They want money out of companies that want to manage large numbers of them. So once we've done all of that, what does this thing actually look like? That'll probably be a good thing to show you next. If you like to find the right tab, here we are. So if I put in my public IP address and port 8443, it will take me here to my login page of my Woodpecker server, and I'll have to log in with the GitHub credentials. So I've set the Woodpecker open to true originally to do my initial one. It's now set to false, and it still works. If I click on that, because I've logged in before, I've got all the session caching set up, or Chrome does all that for me. I don't have to put any credentials in. When you do it for the first time, you'll have to go through the standard OAuth handshake stuff. So you'll get, you have to log into GitHub, so you have to put in your username, password, possibly get an SMS message or a pass code or something from some other multi-factor authentication device. And then it'll say, oh, you're now logged into GitHub. Do you want to authenticate the Woodpecker CI server? And you have to say yes. And then it'll take you back to this page here. This will be blank when you log in, and you say, I want to add a repository. And when I went down this, I obviously picked my Grandad Does Stuff one, it's already enabled. And what that does is it then uses the information that's configured with the GitHub client ID and the GitHub secret to actually go out to that repository and configure a webhook to come back in, so that when things happen in the repository, the CI system knows about it and can do it. So let me show you that next. I have to be slightly careful I don't go over where I need to be. So here we are. So I'm in my own image. That's my GitHub account. This is a Grandad Does Stuff, the big mono repo. I've gone to settings. Just note that is different. So if I come here, there's another settings that's very different. Well, I'll show you that one in a minute. We need to do that for something else. But here, this is the repo, Grandad Does Stuff settings, or your repo, you set up for your repo settings. And then you set up webhooks. Now, I'm not going to click on that there because that will show you my public IP address, which I don't particularly want to make terribly public or terribly well known. So if I come in here, well, I clicked on that webhooks page. It will say what webhooks are for this repo. And here it is. And you'll see the name of it. And if I click on the edit for that, it will say, we'll send you a post to the URL for all the activities going on. So the payload URL will have your public IP address. And that was one of the things you had to configure in the Woodpecker server. What is the public IP address for your thing? So that was that bit. And it says API hook access token. And again, I just put some gobbledygook text in there just to make things secure. But I say when you register your repository in Woodpecker, it will set all this up for you and show you what it has set up. So you don't have to set up the content type or the secret. I did have to change the SSL verification to disable it. But that's because when I'm setting up the certificates later on to terminate the SSL, I've got a self-signed certificate, which isn't a properly secured, authenticated one. So I have to set the verification off on that. I've now got this set up with just push the event. Before I was having some trouble, before I found this setting, I was having some trouble working out what was coming through. So I did say send me everything, but just the push event is enough for this to work. And all that should be hunky-dory. So we're coming up on there. Okay. So let's come back to my repo. So we've seen the pipeline, we've seen the agent, the server, the configuration. So let's start coming back from Nginx and start working out some of these details that we need to do coming back. So in my Docker Compose file, I need to mount a certificate and a private key for these things. So, let me show you how you do that. I have those are mounted from the local file here. So you've got .server_crt, .server key, which are in my repo here. They're not going to get published out to the repo. You need to generate your own. And if you go to the README file here, it will tell you how to do that. So to generate a certificate, well, it says you need OpenSSL. I'm sure there's probably another program to do it, but OpenSSL is kind of the standard way to do this. And if you OpenSSL --help, hopefully that will give you a page that says, well, yada, yada, yada. If you get an error, you'll need to install OpenSSL. I use Choco or Chocolatey to install OpenSSL. And it's as simple as that if you want to do that. And if you haven't got Chocolatey, you can install Chocolatey with that command there. Now, my machine is about 5 years old. I had to do an operating system build a couple of months ago. And for some reason, although I didn't install it explicitly myself, something I've installed has installed Chocolatey. So I got to here and it worked. I haven't tried this command out, so slightly uncharted territory, but hopefully that will work for you. If not, you'll have to get to the place where you've got OpenSSL installed before you can go to the next bit. The next bit, you have to generate the certificates. So first of all, you have to generate your key. So you have to do OpenSSL, gen key, give it an algorithm, tell it where to store the file, and some key options. There's a 2048-bit key, so that should be good enough until quantum computing cracks this stuff in a few years' time. Then you just have to generate what's called a certificate signing request. Now, normally, when you have a certificate to terminate SSL, it's registered with some signing authority. And usually you have to pay for that as a service, and they validate who you are, and then they're validated by some higher level signing registry, etc. This basically just gives the information that would be stored by some signing authority, but just stores it in a local file. And as a result, you've got a self-signed certificate, which has all the information in it, but it's not trusted, which is why we have to set the disable on the SSL validation in the GitHub webhook. So you're on OpenSSL, yada, yada, yada. It's going to write out this server.csr file. You have to give it a server key as well when you do that. And when you do that, you'll be asked to fill in a page of information. It's not too scary. I'll show you the values I've put in here. So it says you're about to be asked to enter information that will be incorporated into your certificate request. What you're about to enter is called a distinguished name, or DN. There's quite a few fields. You can leave some blank. So it wants a country name. I'm in the UK. State or province. I'm in England. Locality. I'm near Durham. Organization name. Own image is kind of the name I tend to use for all this stuff. An organizational unit, that can be left blank. Common name or fully qualified distinguished name. I just put my name in there. I think email address has to be a valid email address, or valid email address syntax at least. And anything else, it says a challenge password or a company name, and I left those blank. So that gets in my CSR file. Another OpenSSL command, you can read it there. And it's going to take that certificate signing request file, and it's going to sign it with that key there, and the output is the certificate that's actually needed. Okay. So let's come back to my Docker Compose. So that's how those two files get stored into that. So I come into the internet with my IP address 8443 that gets mapped through the broadband router into Nginx. Nginx comes to Woodpecker server. What does Woodpecker server need to know? It needs to know that Woodpecker host and all this information here. So let's start with the syntax. This $ thing means get an environment variable. Now you can either specify it by setting values in the environment variable section of your PC. There's actually a really slick little thing that Docker Compose does. Now just beware, Docker doesn't do it. So when you Docker run, this doesn't work, but this works for Docker Compose. So when you do your Docker Compose up and start this file, it reads a local file in the same direction as it called .env. You can override what that is with another flag on your Docker Compose file, but it's a .env. Now that's got all my secrets in there, so I'm not going to show you what that is, but I'll show you what the template is, and that template will be logged into my repo. So it just says Woodpecker host equals HTTPS, then my public IP address 8443. So come back to Docker Compose here. That Woodpecker host goes in there, and that is what this is going to use to register that webhook into GitHub. Coming back, it's got another couple of secrets in there to do with GitHub about the client and the client ID and the secret. And then it's got a single Woodpecker agent secret. So I come back to my template. It's it's a local secret. It doesn't need to be anything particularly good. It's just to stop anything else that could possibly get to your Docker Compose file. Well, sorry, the Woodpecker server from claiming that it's a valid agent. And if it's got that file, then it's probably got your file system and it's inside your network and it's too late. So I don't think that secret is particularly strong. These other things, are very, very secure. So let me flip back to my settings. So in here, if you come into settings, you'll find there's a section developer settings, and then under OAuth apps, you'll do a new OAuth app and you'll get the information you'll see on the PowerPoint slide here. So new OAuth app, so you'll give it a name. It will give you a client ID, and I've just redacted it out of there. When you're creating it, it will give you that client secret. And it's one of those things where you can copy it when it's created, but now it has, now I can't get that secret back. I think there was an end of it is there, but you can't get the whole thing. So you have to copy it first. It's a one-shot deal. As you go through, you have to copy that. You give an application name, and sorry, that was me just clicking on that slide by mistake. You have to give it an application name. You have to give it your homepage URL. So as you do that OAuth handshake and your Woodpecker application is saying, log in to GitHub. When GitHub has successfully authenticated you, it knows where to pass you back to. So it needs that homepage URL. This is the authorized callback to say, this is a token you can store and use that to authorize this user in future. And it's that client ID and client secret you go through when you create this that you need to register in this file here, your .m file. Okay, so that's all worked extremely well. Now, for the eagle-eyed amongst you, I think you've seen there's a little red cross there. So that's not very good, is it? So let's just dig into this. And see the last branch here has failed. So what happens is when I pushed to that branch there, it ran my pipeline script. So first of all, it has to clone the entire repository, and then it does the Solar controller tests. And in fact, that's probably an interesting moment to do a digression on this. For lots of these things, I want to run tests. And my idea originally was I'd have a different pipeline file for each one of these directories. I've only been doing this about a month, and I've got 4 of them. By the end of the year, I'll probably have 50 of them, and I'd have 50 different files here. The problem with that approach is that I would have to, for each one of those pipelines, clone the repository. So I make a change anywhere in the repo, and I'd have to clone that repository for the pipeline and then run the step that's after it. So I think now what I'm going to do is just have one pipeline, which will have that clone step you saw in there, and then it will have a step for each directory, which is conditionally run. So those steps will only run if there is a change in that directory. So for example, my photo organizer project, which I haven't recorded yet, will probably have some tests. So there'll be another step block like that, the photo organizer with the corresponding changes. But let's come back to where I was, and we saw something was broken. So if I come down to the tests, it comes down here, is run my discover tests. And it says there's a failure in my int4 that 1 doesn't equal 2, which is indeed true. So let's go and fix that and prove this all works. So if I come into my, here we are. If I come into here, I can come into Solar controller, come into my test directory, and these tests are just there so I can test whether my CI pipeline works. I'm not currently testing this at all. Now here's a test that's broken. And indeed, 1 doesn't equal 2. So what I'm going to do is I'm going to fix that test. Even I can probably assume that's going to work without having to run it locally before I push it up. I'm just trying to see, here's my Woodpecker 2 branch that I'm currently on. So I show you this. It did say this branch was running on Woodpecker 2. I'm going to come back to here. I'm just making this slightly smaller, if I can do that. Or at least move this out way a little bit. I just want to be able to show you this number. That means no things are running currently in my Woodpecker server. So that is, oh, I should explain. This is a Chrome browser running in full screen mode, by the way, in the background. And the reason for it is I wanted to hide the address bar on the top, because again, it's got my public IP address in. So maybe I'm paranoid about these things, but I thought it was best to do that. So here, I'm in here. If I look at the commits, my test file here, solar controller tests, and that's the only thing that I'm going to change in there. So I'm going to commit and push that change to my branch, my Woodpecker 2 branch. And if you look at this number up here, as I push the button here, I'm going to do push, and that's going to push it up to there, push 1 commit successfully. That has now clicked in here with a 1. If I just click on that, oh, it's run it already. Very often, if it takes a few seconds to run, it claims it took 6 seconds to run. You get a little Woodpecker symbol packing away here so you can see what it's done. But that now means that my solar controller says it's run 4 tests successfully. Happy days. I should probably, in case you haven't seen it, I'm sure you have, show you what that means to my GitHub. Let's come back. Am I on the right? Bear with me, I've just got myself confused. Grandad does stuff. And I've got a pull request here. This is my Woodpecker 2 pull request based on my Woodpecker 2 branch. And if I come down here, all checks have passed. And that's from the CI Woodpecker pipeline. Probably should have showed that was red before. So I can now squash and merge that, and everything will be all good. So that's Woodpecker CI, why I was running it, how I configured it. If you do like that, hit the like, subscribe button, all those usual kudos things. That would be much appreciated. And any comments, put them down below, and I'll try and get you some answers.